Welcome to a quick introduction to our paper, Context by Proxy, Identifying Contextual Anomalies Using an Output Proxy. Our goal is to validate the so-called timeout process in vehicles. While using your car, it is in one of three main states. While driving, it's active. When you've turned off the engine, it's paused. When you've left the car, eventually it should be in the active state, and it's important to reach the inactive state, otherwise battery charge would be wasted. However, it is hard to validate the timeout process. First of all, there is no fixed timeout sequence. So when you, for example, activate the air conditioning, the timeout could be postponed. Secondly, cars are complicated. There are thousands of interrelated components. When going from active to inactive state, there are around 1 million messages on the communication buses, or even more. So if you want to judge the overall context, it becomes a hard task. We want to automatically find contextual anomalies. We did so by teaching an RNN about the timeout process. As input, we gave the RNN the entire system context. So the timer message was sent, where it originates from, and its value. We still don't know a fixed sequence of the timeout process, but we know one thing, that the timeout should come closer at every time step, otherwise battery charge is wasted. So we use a synthetic label, which we call the output proxy, in this case the time to the next timeout. Because this proxy quantity has a known behavior, so that we know at each time step whether this behavior is anomalous or not. Here you can see the estimated output proxy for a normal real-life sample. Whenever there is a new message on the communication bus, the time to the next timeout is re-evaluated. The gray line is a synthetic label used for training samples. As you can see, the general downward-facing trend has been successfully learned, with 2 deviations. In our paper, you will find an explanation for these, and also a discussion of anomalous examples. Thank you so much for watching, and see you at KDD 2019.